Hello, this presentation is titled Random Koch Curves generated in Raku. My name is Anton Antonov. Today is September 1st, 2024. So you can see here I'm generating some random Koch curves. I'm also filling them in with certain color. You can see also the regular Koch curve, or also known as Koch snowflake, is being placed here upside down, kind of like a reflection, not really a reflection though. It's just concatenating two different plots. Okay, so what is happening here? I'm going to actually zoom out first. So here we start with this original shape. This is for the classical Koch snowflake curve. We're starting with this original shape, and every segment, every line segment is being replaced with a copy of this piecewise linear curve, right? And if I do this, say, with 2 iterations, what I said is just going to be obvious. Let me do 3 iterations. Let me just go to 5, and so this should probably look familiar. This is the classical Koch snowflake. Let me return to 1 iteration. So we can randomize this. So we can randomize the height, the width, and also the position of the tip from the beginning, say, from one of the ends of the curve. And this is what is happening with this randomized generation. So before going further, I would like to mention that I took the idea and the general algorithm from this Wolfram function repository entry, random Koch curve by Sander Hussmann. And yeah, we can see here this legend is just what I said about the parameters. The function itself is from the package JavaScript D3, Raku package JavaScript D3, and also uses the distributions from the Raku package statistics distributions. So this here, what you see is the presentation is in Visual Studio Code integrated development environment. I'm using a Jupyter notebook with a Raku chatbook kernel, and because the Jupyter framework is web browser technology, we can render init JavaScript. So this is what this function GSD3 random Koch curves does. It generates a JavaScript code, and that is being rendered in this browser, headless browser. There's also, if you don't want to use this, like notebooks and Visual Studio Code, you can generate random Koch curves, or regular ones, if you will, with the command line. So this is what I'm showing here. So yeah, basically the generated code is HTML. It's being dumped into a file, and then I'm opening this dumped HTML file with the system browser. All right, so let's look into some examples. Here I'm using constant distributions. They're not exactly distributions, they're just constants, right? So if I do this, it's going to be a little bit more clear how this is being influenced. And so if I use deeper recursion, we might get some more complicated curves. So here we're using the distributions, so obviously, right? And so every time here I'm going to be running this, we're going to get different results. All right, so I would like to mention also that if you want to make your own renditions, you can generate the random Koch curve in this way, the points for it in this way, and then render it with in some alternative way. So here I'm using the function textListPlot from the package textplot, right? So you can see this should look a little bit like the curve which is being generated here. Actually, let me do a smaller number of iterations, and maybe now it's going to be a little bit more clear, the regularity of the generated curve. Okay, so we can degenerate the process a little bit, and instead of having this kind of snowflakey but random shapes, we can get this forest-like shapes. And of course, we can try to do multiple ones with random selections at every step. So let me zoom out here. So I call this a sequence of funguses, so yeah, you can see random generation with different with the same number of recursion iterations, but and the same distributions, but every time, although the same distribution is being used, every time we get this kind of different sizes, different heights, and so forth. Okay, same with the forest. And so here, this actually showcases something else. We can specify the stroke color, the fill color, and I'm basically selecting them at random. And also here, what is happening, I'm selecting the number of iterations between 5 and 6, right? And so we get this kind of look. All right, so the more interesting part is that if we take the code of this function Koch curve, so JavaScript d3 random Koch curve, this is the function I used here, right? This one here to generate the points. So just the code which generates the points, not the actual rendition code. So if I take that code and if I put it into a large language model, what is going to happen? This is going to take a while, so I'm going to render some image here, and then I'm going to put this in. Okay, so yeah, you can see from that code we generated this image. This is using DALL-E, right? DALL-E 3. So great, but this actually also looks pretty good, I have to say. Actually, it's one of the better ones I generated, but it's also a little bit cheating. So here you can see with this LLM prompt, I'm saying analyze the following code carefully and make an artistic rendering of how you think the result would look like. All right. Yeah, but this gives lots of hints. Namely, we do say Koch curve, and we do say, I don't think we say snowflake, but the name Koch and curve and some of these formulas here, it's already sufficient to start making some sort of snowflake-like structures or images. Now, if I take the same code, and so let me clear this here. If I take the same code but I anonymize it, so I remove the Koch part, right? So from this, let me remove this one here too. So if I instead of Koch curve, I have some kind of generic name, and here also I have some generic name, and also here I have removed Koch whatsoever. Then this is a more faithful test, so to speak, of how DALL-E is going to be analyzing this code, or is it analyzing it at all, and what we're going to get. And after a while, I mean, I'm going to tell you, it's not going to be that much of a Koch snowflake. It does actually have some rendition. I think it's pretty much taking into account the different, formulas being applied here. I'm not saying it's not analyzing the code, but definitely it's not. If we do this repeatedly, it's not that snowflakey, so to speak. And you can see in these images here I'm going to show. We can recognize when it was anonymized and when it was not. So obviously this was the original thing I showed. Yeah, Koch name was in the code, right? Here this is actually just the anonymized code, and pretty good actually. I like this. I like how Raku was recognized. So it wasn't analyzed, the code was analyzed. I don't explicitly say it's Raku. It was recognized, and Raku kind of mascots or monikers were being put in the image. Again, here Koch was there, the name Kochs were there, and here you see it's again just with the formulas and so forth, right? Yeah. All right, and here this is this here again the code was not anonymized. So all right, pretty much this was it, and thank you for your attention.